Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths, which is also called Math with Sandeep. Now, in this particular video, we'll be seeing how to find limits using standard formula. So, and this is our standard formula. Okay, now limit x approaches a, x power n minus a power n divided by x minus a is equal to n into a power n minus 1. So, using this particular formula, we'll see how to solve many questions. But before solving the questions, first let us see how to prove this formula, and at the same time this is another formula. So this is also mostly used in many of the questions. We will see how to prove these two, and then we will start solving problems based on standard formula. Okay now, so we will see the proof of this first. So okay, this is what we are going to prove, but before proving this, first let us revise the binomial expansion of rational index. So if you remember from binomial theorem chapter, you should have learned that 1 plus x whole power n, where n is any rational number. Okay now, so except n can be any rational number. So for this, the binomial expansion is given by 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x cube and so on. So if you pick any one particular term, the numerator is product of 3 consecutive natural numbers starting from n, and the denominator is 3 factorial. If you are taking three numbers in multiplication, denominator is 3 factorial and x power will be 3. Similarly, if you take product of 4 consecutive numbers in the numerator, then you will take 4 factorial in the denominator into x power 4 and so on until infinity. There are infinite number of terms in this particular expansion. We are going to use this particular expansion to prove that. Let us see how to prove it, but remember that while using this formula, mod x will be less than 1. This is the condition. Only when mod x is less than 1 we can use this formula. Okay, now what happens if x is approaching 0? If x is approaching 0, dear students, you can understand. For example, x is approaching 0 means let x is 10 power minus 10. And the higher powers of x, what about higher powers of x? X square will be 10 power minus 20, x cube will be 10 power minus 30, x power 4 will be 10 power minus 40 and so on. It might be not correct to ignore x value, but I can always ignore higher powers of x, because look at their values. X square is 10 power minus 20, which is very small. X power 3 very small. X power 4 very small. So in some questions, particularly when x is approaching 0, we can ignore the higher powers of x. Since we are ignoring the higher powers of x, if x is approaching 0 in this expansion, what happens? Then 1 plus x whole power n will be approximately equal to 1 plus nx. So what about the remaining terms? We are ignoring them. I am ignoring from powers of 2. Okay, now from x square I am ignoring all of them. From x square term I am ignoring all the terms. But in some problems we will start ignoring from x cube, from the x cube term. In some problems we will start ignoring from x power 4. Here we are ignoring from the powers of 2. Okay now, so we can ignore the x square term, x cube term and so on. What is the reason that we are ignoring them? Because their values are almost negligible. For that reason we are ignoring the higher powers of x. So that is, in this case, in this expansion I am ignoring x square term, x cube term and so on. Okay now, so then 1 plus x whole power n is approximately equal to 1 plus nx. So this is what I am going to use while solving the problems based on standard formula. Okay, now we will take 1 plus x whole power n approximately equal to 1 plus nx. I will use it in many of the questions while solving in today's video. Okay, please observe that I am ignoring from x square, x cube, x power 4 and so on. Okay, so now let me prove the standard formula using this particular fact. And remember, I can use this when x is approaching 0. Okay, now let us see the proof. So I will take LHS. LHS is limit x approaches a, x power n minus a power n divided by x minus a, where a is any real number, but particularly a is a positive real number and n can be any real number. Okay now, so now limit x approaches a means, dear students, it means x is equal to a plus something, some h, where h is approaching 0. Already we have used this concept in first few videos of limits chapter, particularly when we are solving the questions on LHL and RHL. Okay, so fine, here h is approaching 0. In that case, what I will do is, instead of x, I will take a plus h. So a plus h whole power n minus a power n divided by, instead of x I am going to use a plus h minus a. So plus a and minus a will get cancelled, and next I wanted to convert it in the form of 1 plus x whole power n. Remember this. I wanted to convert this in the form of 1 plus x whole power n in such a way that 1 plus whatever is there, it should be approaching 0. Keep this in mind. If you take h common, you will get a by h. And a by h is approaching infinity. A by h is not approaching 0 because h is approaching 0. Na? So do not take h common, take a common in these two terms. And when a comes outside the bracket, it will take the power. So a power n into, I took a common in these two terms. Na? Here you will get 1 plus this is h by a whole power n as it is minus a power n whole divided by h. So here in the first term and second term, we can take a power n common, and a power n is independent of the limit. You can take it outside. A power n into limit h approaches 0, 1 plus h by a whole power n minus a power n divided by h. Dear students, as h is approaching 0, h by a is also approaching 0. H by a is also approaching 0. So for that reason, what we can do, we can write 1 plus x whole power n approximately as 1 plus nx, correct or not? 1 plus n into x. So if that is the case, what happens here? A power n into limit h approaches 0, 1 plus n into h by a, 1 plus n into h by a, okay na, minus, I'm sorry, I have taken a power n common here and here, right? So here we have 1, okay, minus 1 whole divided by h. So plus 1 and minus 1 gets cancelled, into h by h will get cancelled, you will get n into a power n divided by a is a power n minus 1. Therefore, we have proved that limit x approaches a, this function is equal to n into a power n minus 1. So we have used it using binomial expansion. We can also prove it using L'Hospital's rule. If you use L'Hospital's rule, the proof is very easy. I hope all of you know what is L'Hospital rule, but very soon I will upload a video on L'Hospital's rule and its applications also. But in case if you are interested to know how to prove this using L'Hospital's rule, I will show you here. Simply, what is L'Hospital's rule? When x is approaching a, if f of x by g of x, this rational function is taking 0 by 0 form or infinity by infinity form. Okay now, so if f of x by g of x is taking 0 by 0 form or infinity by infinity form, then we can say that limit x approaches a, f of x by g of x is equal to limit x approaches a, f dash of x by g dash of x. And we can continue again. We can also write it as limit x approaches a, f double dash of x divided by g double dash of x, and the process can continue and so on until we get a finite answer by substituting x as a. Okay now, but remember, we can only find the derivatives if the derivatives exist at x is equal to a. Okay, so however, I'll detailedly explain L'Hospital's rule in a different video. For now, let me prove that this formula is equal to n into a power n minus 1 using L'Hospital's rule. Okay, let me take limit x approaches a, x power n minus a power n divided by x minus a. When I substitute x as a, the numerator will be a power n minus a power n, which is 0, and denominator is a minus a, which is 0. It is taking 0 by 0 form. So let me use L'Hospital's rule, and according to L'Hospital's rule, the derivative of numerator is n into x power n minus 1. Which one? X power n derivative is n into x power n minus 1 minus a power n is a constant, and the constant derivative is 0 whole divided by x derivative is 1 minus again number derivative is 0. So I am getting limit x approaches a, n into x power n minus 1. Now you can substitute x as a, you will get n into a power n minus 1. Over. The proof is over. If you use L'Hospital's rule just like that, you will get the answer. But I am not using L'Hospital's rule in many of the problems just because you should know the original method of solving the problems. If you simply depend on shortcut, obviously in exam you can depend on shortcut, but while learning, the process is very important. You should learn the subject. If you want to learn the subject, you should learn the method. We cannot always depend on shortcuts, okay na? So I will not use L'Hospital's rule while solving these problems. You know the original method. Later we will also see how to get the answers using L'Hospital's rule. You can try it, but remember, L'Hospital rule can be used when the limit is approaching 0 by 0 form or infinity by infinity form. We will discuss more about L'Hospital's rule in some other time, in some other video. Fine. Now let us also prove the next form. We will see how to prove limit x approaches 0, 1 plus x whole power n minus 1 divided by x equal to n. That is simple. Use this fact, you will get the answer. Will you try it? Use this particular fact. You can take 1 plus x whole power n approximately as 1 plus nx. You will get the answer. You can do it yourself. Okay. Now let us get into solving problems. First one, a basic application of this particular formula is first one. So what is it? The first question is, so what is it, dear students? X power 6 minus 729 by x cube minus 27. So we have to find the limiting value of this function when x is approaching 3. First of all, if you directly substitute x value as 3, you will get 3 power 6 minus 729. 3 power 6 is also 729. So you will get 0 in the numerator and similarly 0 in the denominator. So you are getting 0 by 0 form. After observing, we have to understand that obviously we can solve this question using standard formula, the first one. Okay, let me write this as x power 6 minus 729 after prime factorizing with 3, you will get 3 power 6 divided by x cube minus 27 is 3 cube. And if I want to use this form, limit x approaches a, x power n minus a power n divided by x minus a, then for x power n minus a power n, the denominator must be x minus a. Okay, now here I want the denominator as x minus 3, both for the numerator and also for the denominator. So let me divide with x minus 3 in the numerator and denominator. Divide the numerator with x minus 3 and the denominator also with x minus 3. If that is the case, now I can apply limit for the numerator and also for the denominator. So what is it, dear students? If you use standard formula, the answer is n into a power n minus 1. So therefore the numerator becomes what? N into, which means 6 into a power, which means 3 power, n minus 1, which means 6 minus 1, whole divided by. Similarly, limit can be applied for the denominator. Okay, n into, so 3 into a power 3 power, n minus 1, 3 minus 1. Okay, so 3 1s are 3 3s are. Numerator is 3 into 3 power 5. That means 3 power 6, and denominator is 3 square, so you will get 81. So the answer is 81. So the answer for this question is what? 81. So I hope the question is very simple. We will go with second question, another simple question. So very simple question and basic application of limits using standard formula. If x approaches 3, I'm sorry, a small correction here. This is not a power n, this is 3 power n. Okay, x power n minus 3 power n divided by x minus 3. Okay, so here is the question. If the limiting value of this function is 108, where n is a natural number, then find the value of n. So obviously you can solve the question using L'Hospital's rule or also standard formula. We know the formula directly for LHS na. So what is it? This is in this form only, right? So n into a power n minus 1 is LHS. And 108 you prime factorize with this number 3. For example, if you have 5 power, then prime factorize the given number with 5. But here we have 3 powers now. So obviously prime factorize with 108 with 3. So if you take 108 and if you prime factorize with 3, 3 3s are 9, 18 means 3 6s are, again 3 12s are, and 3 4s are. So dear students, what we have got is 4 into 3 into 3 into 3 is 3 cube. And please observe, I can rewrite it as 4 into 3 power 4 minus 1. n into 3 power n minus 1 is equal to 4 into 3 power 4 minus 1. By comparing, n value is 4. So n is a natural number which is equal to 4. Simple question only na. We will go with next question. So we are supposed to find the limiting value of this particular function when x approaches 1. And observe it contains summation also. Okay, let me give summation for this. Only this term needs summation because only this term depends on r. Okay now, so what happens? Obviously, limit x approaches 1. The numerator, if you take summation for x power r, you have to understand that the summation is only for this. Okay, not for 50. Summation is only for this. You can also change the question. So this means what, dear students? X power 1 summation means plus x square plus x cube and so on up to x power 50. Minus 50 is there. Minus 50 I can write as minus 1, minus 1, minus 1 and so on. Minus 1, how many times? This is taken 50 times. So minus 1, minus 1, minus 1 and so on. Minus 1 is minus 50 only na. So I just wrote minus 50 like this. Whole divided by x minus 1. See how I am rearranging the numerator. Limit x approaches 1. X power 1 minus 1 plus x square minus 1 plus x cube minus 1. See, here we have 1, 2, 3 and so on 50 terms. Here also we have 50 times minus 1. Correct or not? So that means what? One person from here will take 1 minus 1. Correct or not? Another person will take another minus 1. So they can be rearranged like this. And so on. Final x power 50 will take minus 1. Are you understanding? The same numerator is rearranged like this. Whole divided by x minus 1. Can I separate it? How do I separate? For this one x minus 1, for this one x minus 1. Here also denominator x minus 1 and so on. Here also denominator x minus 1. So now limit can be applied for all. You can use standard formula. Obviously this value is 1. So here 1 means 1 square, here 1 means 1 cube and so on. Here 1 means 1 power 50. If I use standard formula, what is the value of this? N into a power n minus 1, 2 into a power 2 minus 1. That means 2 into 1 power 2 minus 1 plus 3 into 1 power 3 minus 1 and so on. The last term is 50 into 1 power 50 minus 1. So what is our answer, dear students? 1 plus 2 plus 3 and so on up to 50. This is 1 power can be ignored. 1 plus 2 plus 3 and so on up to 50. And using sum of first n terms formula, n into n plus 1 by 2. N into n plus 1 by 2 where n is 50. Okay. So the answer is what? 50 into 51 by 2. We can calculate and we can write the answer. 2 ones are 2, 25s are. So 25 times 51. So you can calculate and you can write the answer. Okay now, I think it is 1275. Okay, we'll go with next question. So here is our next question. Limit x approaches 1, root x plus root of root x plus root of root of root x plus root of root of root of root x minus 4 whole divided by minus 1. So don't think that it is a complex question. It's actually a simple question. If you have completed third question, just think how to solve this question. You'll get the answer in no time. If you have done third question, pause the video and try it yourself. Obviously, you'll get the answer. Very easy question. Okay. So how do we solve it? Just understand that root x means what? My x power 1 by 2. Root of root x means what? X power 1 by 2 whole power 1 by 2. So you'll get x power 1 by 4. Root of x means x power 1 by 2 power 1 by 2 power 1 by 2. So 1 by 2 into 1 by 2 into 1 by 2, you'll get 1 by 8. And this is obviously x power 1 by 2 whole power 1 by 2 whole power 1 by 2 whole power 1 by 2. So 1 by 2 is multiplied with itself 4 times. You'll get 1 by 16. I hope you understand this. What I'm trying to say is, for example, if you take this x power 1 by 2 whole power 1 by 2. So 1 by 2 into 1 by 2, you got this. And what is this? Another whole power 1 by 2 will be there. Square root of square root of square root. Square root is nothing but power 1 by 2. If you multiply these three, you'll get power 1 by 8. And what is this? Another whole power 1 by 2 will be there. So multiplying this, you'll get power 1 by 16. Okay now. And please observe, minus 4 is there. I can write as minus 1, minus 1, minus 1, minus 1 whole divided by x minus 1. So how am I rearranging this function? Limit x approaches 1. First I'll write x power 1 by 2. I'll take minus 1 here with common denominator x minus 1. Plus I'll write x power 1 by 4. I'll take second minus 1 divided by x minus 1. Plus I'll take x power 1 by 8. Next I'll take minus 1 from here with the denominator x minus 1. Plus I'll take x power 1 by 16. I'll take minus 1 here divided by x minus 1. Now you can use standard form. You can use standard formula, correct or not? Here 1 means you can write it as 1 power 1 by 2. Here 1 we can write 1 power 1 by 4. Here 1 we can write 1 power 1 by 8. And here we can write 1 power 1 by 16. So what is the final answer, dear students? X approaches 1. This one. What is it? N into a power n minus 1. Correct or not? Plus. Again n into, that means power 1 by 4 into a power, that means 1 power n minus 1. Plus. Here n into a power n minus 1 plus again 1 by 16 into 1 power 1 by 16 minus 1. 1 power any number is 1 only, so we can ignore. What we will get? We will get 1 by 2 as first term, 1 by 4 as second term, 1 by 8 as third term, and 1 by 16 as fourth term. Okay, now if you add all these 4 terms, I think you will get 15 by 16. Check it out. Into 8 into 8 into 4 into 4 into 2 into 2 into 1 into 1. So 8 plus 4 12, 12 plus 2 14, 14 plus 1 15. Yes, the answer is 15 by 16. The answer is 15 by 16. So that is the answer for our fourth question. So very important model. Do practice it. We'll go with next question. Here is our next question. When x approaches 0, this particular function value is 1 by 3. Then what is p comma q? These are important kind of models. Please listen carefully of how to solve this particular question. First thing is, when x is approaching 0, okay, now if I directly substitute x value as 0, the denominator is becoming 0. But what about the numerator? If I substitute x as 0, p plus q into 0 minus 1 minus 0 power 1 by 3 is 1. So what I am getting? P minus 1. Okay, I got p minus 1 in the numerator and I got 0 in the denominator. Let me tell you one thing. If this number is not 0, if p minus 1 is not 0, if it is any other finite number, plus 3 or minus 3, obviously our answer cannot be 1 by 3. Our answer will be plus infinity or our answer will be minus infinity. Correct or not? If the numerator p minus 1 is not 0, and if our numerator is some other real number, then you will get 3 by 0, which I mean you'll get, of course, if you take the numerator as 3, you'll get 3 by 0. That means what? The answer is plus infinity. And if the numerator is any other negative number, you will get minus infinity. You will not get 1 by 3 as the answer. And remember, in these kind of models, when denominator is approaching 0, if the answer is finite number, then numerator also must approach 0. That means the question must take 0 by 0 form. If denominator is approaching infinity, the question also must approach infinity. Then only we will get finite answers like this. Keep this in mind. Of course, I will discuss problems like this. Many models are there. We will discuss it. Okay, now one by one. Anyhow, let me solve you this particular question. So as I told you, since the denominator is approaching 0, the numerator also must approach 0. Therefore, p minus 1 is 0, p is equal to 1. So directly we can answer this. No sir, I don't want to answer like this, means we will do one thing. Let us go to the question. Obviously p will be 1 only, but since x is approaching 0, dear students, minus 4x is also approaching 0 only. Minus 4x is also approaching 0. And what happens? We can use this form, 1 plus x whole power n is approximately 1 plus nx. If that is the case, 1 minus 4x whole power 1 by 3 is approximately what? 1 minus this into this, 4x into 1 by 3. So we can write this here. So limit x approaches 0, p plus qx minus of 1 minus 4x into 1 by 3, 4x by 3 whole divided by x, okay, equal to 1 by 3. So rearrange the numerator. P minus 1 is constant term plus remaining 2 are x terms now. So if I take x common, here you will get q, minus into minus will be plus 4 by 3 whole divided by x. Okay, you can separate the common denominator x. When I separate the common denominator x, here by x and here by x equal to 1 by 3. Dear students, now x and x gets cancelled. This is some number. But look at this. P minus 1. What happens if P minus 1 is not 0? Some real number divided by 0. Real number divided by 0 will become infinity or minus infinity. Then the answer cannot be 1 by 3. The answer cannot be 1 by 3. That means what? That means when denominator is approaching 0 here, even the numerator must approach 0. So P minus 1 is equal to 0, P is equal to 1. Okay na? So now I'll get back to this. I'll rewrite it like in the previous form. So dear students, P minus 1 must be 0. Okay na? 0 plus, yes. Now when P minus 1 is 0, q plus 4 by 3 into x by x is remaining. Now these two will get cancelled. This is gone. P minus 1 is 0, P is equal to 1. What we will get? Q plus 4 by 3 in LHS and 1 by 3 in RHS. Take 4 by 3 right side. Q is equal to 1 by 3 minus 4 by 3. You will get Q is equal to minus 1. Therefore P is plus 1 and Q is equal to minus 1. 1 comma minus 1. So this is how we can solve this question. We'll go with next question. Okay, this is our sixth question, last question in this video. But before solving this, I just wanted to ask you one question. Why did this particular question come under this concept, under standard limits? Because look at this, the base is a binomial, 2x minus 5 or 3x minus 8 or x plus 5 or x plus 6. All these are binomials. And what about their power? Here power 1 by 2, power 1 by 2, power 1 by 3, power 1 by 3. So we have binomial expansions only with rational index, which means I am going to use this concept. 1 plus x whole power n is approximately 1 plus nx if x is approaching 0. Because of that reason, because I am using this particular concept, we have got this question under this concept. Okay na? It's very important to study the question and we have to think how to answer a question. Okay na? Anyhow, if I directly substitute x as 3, root of 3 plus 6 is root 9, which is 3. 2 into 3, 2 3s are 6 minus 5, 1. So 3 into 1 will be 3. The numerator is 0. Similarly, if I substitute x as 3, 3 plus 5 is 8. And cube root of 8 is 2. Again, 3 3s are 9, 9 minus 8, 1. Cube root of 1 is 1, 2 1s are 2. So 2 minus 2, 0. This question is taking 0 by 0 form. And obviously, I am going to use what? This particular form. But I can use this form only if it is 1 plus something, where that something is approaching 0. So what to do, please observe carefully. What I will do is, this will help me. Do one thing, how to make sure that this is approaching 0, just take 3 left side. X minus 3 is approaching 0. Correct or not? Who is approaching 0 here? X minus 3 is approaching 0. And let y is equal to x minus 3. Now rewrite this question, you will get clarity. Okay now, dear students, remember y is equal to x minus 3. So if x minus 3 is approaching 0, then y is also approaching 0. So how is the question changed now? Limit, not x approaches 3. Limit y approaches 0. So instead of x, we are substituting what from here? Y plus 3. Correct or not? X is equal to y plus 3 only. Na? Substitute that everywhere. X as y plus 3 plus 6 minus 3 into square root of 2 times x is y plus 3 minus 5 whole divided by cube root of x is y plus 3 plus 5 as it is minus 2 into cube root of x is y plus 3 minus 8. So then the question is what? Limit y approaches 0, y plus 9, of course the power is 1 by 2 or square root. Let me keep it as square root, later I will write as power 1 by 2. Minus 3 into square root of 2 into y is 2y and 2 3s are 6 minus 5 will be 1 whole divided by cube root of y plus 3 plus 5 is 8 minus 2 into cube root of 3 into y is 3y and 3 3s are 9 minus 8 is 1. Right? So now observe one thing carefully. Look at these numbers. Under the square root we have 9, which is a perfect square. Under cube root we have 8, which is perfect cube. And I wanted to convert it in this form. So what am I going to do, dear students? what am I going to do is, let me take 9 common in these two terms and 8 common in these two terms. Why should I take 9 common? To get this form. Why should I take 8 common? To get this form. Is it clear? So if I convert it, so it is limit y approaches 0. Here and here if I take 9 common, and if 9 comes out of the root, it becomes root 9. Root 9 is 3. So 3 into, I took 9 common now. So this 9 becomes 1 plus this y becomes y by 9 and root becomes power 1 by 2. Is it clear? Okay. Minus 3 into, I'll rewrite it as 1 plus 2y whole power 1 by 2 whole divided by, and if I take 8 out of the cube root, 8 comes outside and it becomes cube root of 8. Cube root of 8 is 2. 2 into 8 becomes 1 plus y becomes y by 8 and whole power, cube root means power 1 by 3. Next minus 2 into, I can write it as 1 plus 3y whole power, what is it, cube root na, power 1 by 3. So now dear students, in numerator in both terms I can take 3 common and I can take 2 common in the denominator na. So 3 by 2 will come outside, limit y approaches 0, and let me use this form. 1 plus x whole power n is approximately 1 plus n into x, because x is approaching 0. Correct or not? If y is approaching 0, y by 9 is also approaching 0. 2y is also approaching 0. Y by 8 is also approaching 0. 3y is also approaching 0. Okay, now I'll erase this part and I'll continue the solution here. So 3 by 2 into limit y approaches 0. What happens here? I took 3 common already. 3 came outside. So I can write this term as 1 plus y by 9 into 1 by 2. So y by 9 into 1 by 2 according to this form. Okay, now minus, please keep the bracket. For binomial, minus is there outside na. Keep the bracket. So 1 plus 2y into 1 by 2. 2y into 1 by 2, because I have used this form. Whole divided by, same story. I took 2 outside already common. 1 plus y by 8 into 1 by 3. Y by 8 into 1 by 3 minus, and keep the bracket, 1 plus 3y into 1 by 3. So we are very close to our answer. Plus 1 and minus 1 gets cancelled. So 3 by 2 outside, do not forget that. Y by 18 minus y whole divided by y by 24 minus, not 3 cancels na, minus 1. So 3 by 2 into, you can take y common in the numerator and y common in the denominator. You can cancel y and y. You will get 1 by 18 minus 1 divided by 1 by 24 minus 1. So what do we get? 3 by 2 into, the numerator is minus 17 by 18. The denominator is minus 23 by 24. Okay na. So minus and minus gets cancelled, and 6 3s are 6 4s are. Okay, so let me simplify it. So 3 1s are 3 1s are, and then 2 1s are 2 2s are. Okay na. So finally, what is the answer that we have got? 17 divided by 23 by 2. 23 by 2 or 17 into 2 by 23. The answer is 34 by 23. So that is the answer, dear students. So do try this question once again. Certainly you'll get clarity in this. There is no doubt in that. I hope particularly 6th question you have to practice. Then you will certainly remember it. Do practice all this, dear students. Okay now. So that's it for today's video. So these are the problems under limits in standard form. Certainly we will find more models under limits in standard form. We will upload some other time. Do repeatedly practice. Don't forget that. I hope you understood this concept and problems. So do like the video if you have understood it. Share it with your friends and give any feedback if there is something in comment section. Subscribe if you are new to the channel. Don't forget this. Subscribe. We'll see you all in next video. This is M. Sandeep Kumar. Take care.